Okay, hi guys, this is notes over how to solve quadratic equations using the quadratic formula. One thing to note is that we can only use the quadratic formula if the equation is already in standard form, so that ax squared plus bx plus c equals 0. Okay. And then if you recall from Algebra 1, our formula for the quadratic is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you remember in Algebra 1, the way you guys most likely were taught to remember this was through a song. So I'm going to go ahead and sing it, see if it rings a bell. So it went, x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So if you want to look that up and listen to that song on repeat, go ahead and go onto YouTube and type in the quadratic formula song, and it's to the rhythm of Pop Goes the Weasel. Excuse me. Okay, let's look at example 1. So in example 1, the first thing we're checking to see if it's in standard form. Since it is in standard form, I'm going to label my A, B, and C. So A is 1, B is 3, and C is negative 5. I'm going to write my formula, and then I'm going to start plugging everything in. So I have x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 all over 2 times 1. Notice how I plugged in all the A, B, and C values. Now I'm going to simplify. So I get x is equal to negative 3 plus or minus. If we simplify the discriminant, that's everything under the radical, 3 squared is 9, and negative 4 times 1 times negative 5 is positive 20. So that means under the radical, we have 9 plus 20, which is 29. So the square root of 29 all over 2. This is going to be my answer because 29 is a prime number and we cannot reduce it. So this tells us that we have 2 real roots. Okay, let's look at number 2. So notice in number 2 that this is not in standard form. We have to take everything on the right side and move it over to the left because we want that side equal to 0. So I would subtract 12x and add 4 to the other side. So I have 25x squared minus 8x minus 12x plus 4 equals 0. Then I would combine the like terms in the middle, and I get 25x squared minus 20x plus 4 equals 0. Now I can label my A, B, and C. So my A is 25, my B is negative 20, and my C is 4. So plugging everything into the formula, I get x is equal to negative b. Since b is already negative, I'm going to put a positive 20 plus or minus the square root of b squared. So negative 20 squared is 400 minus 4 times a, which is 25, times c, which is 4, all over 2 times a, which is 50. So I have x is equal to 20 plus or minus, we already have that 400, and if we multiply negative 4 times 25 times 4, we get negative 400. So 400 minus 400 gives us 0. So we have 20 plus or minus 0 divided by 50, okay? We don't need that plus or minus 0, so technically we just have 20 over 50, which reduces to 2/5. Okay. So instead of 2 roots, we now have 1 root, and it is real. So 1 real root. Okay. Let's look at example 3. Example 3, remember in order for it to be in standard form, this side needs to be equal to 0. So that means we need to add the 10 over to the other side. So I get 10x squared minus 4x plus 10 equals 0. Label my A, B, and C. I got A is equal to 10, B is equal to -4, and C is equal to 10. Plugging everything in, I get X is equal to 4 plus or minus the square root of 16 minus 4 times 10 times 10 all over 20. So I get X is equal to 4 plus or minus the square root of 16 minus 400 over 20. So X is equal to 4 plus or minus the square root of -384 over 20. So since we have a negative under the square root, right away this tells us that we are going to get imaginary roots. But we also know that we can reduce the radical 384 by using the prime factor tree. Okay. Again, this is something you should have learned in Algebra 1. If you haven't or you don't recall, make sure you go back and learn that skill or come to tutoring. So doing the prime factor tree, we have to take our 384 and we have to divide all the prime numbers into it, starting with the smallest prime number. So that means we have 384 divided by 2, which gives us 192 divided by 2 gives us 96, divided by 2 gives us 48, divided by 2 gives us 24, divided by 2 gives us 12, divided by 2 gives us 6, divided by 2 gives us 3. Notice how we ended our tree because we ended on a prime number. Now I'm going to go and circle all of my pairs of prime numbers. So I have one pair here, another pair here, and another pair here. So since I have 3 pairs of 2, that's the same as saying 2 times 3, which is 6. That's outside of the square root. And then inside, I take whatever is left over, that 2 and the 3, and I multiply it, and I get 6. Which means the square root of 384 is the same as 6 square roots of 6. So I can rewrite this as X is equal to 4 plus or minus 6I square roots of 6 over 20. We took out that I that used to be a negative inside the square root. And then simplifying this further, I get X is equal to 2 plus or minus 3I square roots of 6 over 10. This is our answer. We have 2 answers, but they're both imaginary. So I have 2 imaginary roots. Okay. Next example. First, I need to put this into standard form by moving over the 2x. So that's going to be minus 2x. So I have 4x squared minus 2x minus 6 equals 0. Notice when I subtracted the 2x over, I made sure that it was in the right position. Now I label my A, B, and C. A is 4, B is -2, and C is -6. And then plugging into my formula, I get X is equal to 2 plus or minus the square root of 4 minus 4 times -6, all divided by 8. Okay. This gives me X is equal to 2 plus or minus the square root of 4 plus 96 over 8, which gives us X is equal to 2 plus or minus the square root of 100 over 8. We know that the square root of 100 is 10, so we're left with X is equal to 2 plus 10 over 8, and X is equal to 2 minus 10 over 8. This becomes 12 over 8, which reduces to 3/2. And then this one becomes -8 over 8, which reduces to -1. So we have 2 answers here, and they're both real. So 2 real roots. Okay, that's the first half. The back part of this, I forgot to clear it. The back part of this is going to be our real world examples. So it says, in your backyard, there is a koi pond that measures 6 feet by 8 feet. You have enough concrete to cover the walkway, which will result in a total area of 120 square feet as shown in the diagram. What should the width of the walkway be? Well, first, we need to find the length and the width length, and the width of this entire thing. So notice we already know part of the length and part of the width. It's going to be that 8 feet and the 6 feet. And then on either side of this, on both sides, there is an additional X that shows the width of the sidewalk on either side. So that means we have our length equal to 8 plus x, which is the same as saying 8 plus 2x. And our width is equal to 6 plus x, which is the same as saying 6 plus 2x. And we know that the area of a rectangle is length times width. They give us the area of 120, so 120 is equal to 8 plus 2x times 6 plus 2x. That's our answer for part 1. Then we need to take that equation and put it in standard form so we can find the roots for this problem. So that means we have two binomials being multiplied, so we're going to use the FOIL method. So I have 120 is equal to 48 plus 16x plus 12x plus 4x squared. Okay, I'm going to subtract the 120 over, so I have 4x squared, and then I'm going to add these like terms, plus 28x plus 48 minus 120 equals 0. So I'm left with 4x squared plus 28x minus 72 equals 0. That's the answer for step 2. And then in step 3, I'm going to use my A, B, and C. So A is equal to 4, B is equal to 28, and C is equal to negative 72 to find my answer using the quadratic formula. So I have x is equal to negative 28 plus or minus the square root of 28 squared minus 4 times negative 72 all over 8. This gives me x is equal to negative 28 plus or minus the square root. And let me get a calculator to simplify that. Well, if these calculators were charged. 1 minute. Okay, so I have 28 squared, which is 784, plus 4 times 72 gives me 1152 all over 8. So this is x is equal to negative 28 plus or minus the square root. So 784 plus 1152. And then I'm going to take the square root on my calculator of 1936. And I get 44 over 8. Well, since we're dealing with a real-world problem, I only want the one that's going to give me a positive length, a positive distance. So that means I take negative 28 plus 44 over 8, and that reduces to 2, which means the width has to be 2 feet. Okay. And then lastly, number 6 says your neighbor is building a fence around his yard. He wants to use his house as one side of the fence to reduce the amount of fencing needed. So let's first draw our diagram in step 1. So here's my cute little house. Okay, hi, here's my little windows, my door, there's my little house. Okay, I want to use one side of my house to enclose my yard. That way, instead of having 4 sides of a fence, I only need 3 sides of the fence. Okay, so let's see, here's my fence here on this side, and then I have a fence on this side, and then I have a fence on this side, and let's pretend that my house was a little bigger here. There we go. Okay, it says he knows that the length of the fence, okay, so the length of the fence is going to be 2 more than 3 times the width. Length is equal to 2 more than 3 times the width, and this is the width. Okay, your neighbor wants to enclose a 250 square feet inside of the fence. Okay, so inside of here is 250. That is our area. Okay. What could the dimensions of the fence be? Then determine how much feet of wood he would need for the fence. So first, setting up our equation, we know that area is equal to length times width. We know that area is 250. Our length is 2 plus 3w, and our width is just w. Okay, that's our answer for the first part. Then we have to take that equation and put it in standard form. So I'm going to distribute that w, so I get 250 is equal to 2w plus 3w squared. Subtract the 250 over, so I get 3w squared plus 2w minus 250 equals 0. That is my answer to step 2. Now I'm going to use that equation, label my a, b, and c. So a is 3, b is 2, and c is negative 250. And then I'm going to plug it into my equation. So x is equal to negative 2 plus or minus the square root of 4 minus 4 times 3 times negative 250 all over 6. Okay, so reducing what's on the inside, I have 4. Oh goodness. I have 4 times 3 times 250, which is 3,000. And it turns positive, so x is equal to negative 2 plus or minus the square root of 3,004 over 6. If I take the square root of 3,004, I get about 54.81. So x is equal to negative 2 plus or minus 54.81 over 6. I only want the positive version of this because it's talking about a real-world problem and distance cannot be negative. So I get x is equal to negative 2 plus 54.81 over 6. Okay, so negative 2 plus 54.81 divided by 6. This gives me 8.802, okay, feet. But if you notice, it doesn't just want what x is. So technically what we just found was the width. So our width is 8.802 feet. Well, in order to find our length, we had the equation L is equal to 2 plus 3W. So this is going to be 2 plus 3 times 8.802, which is 28.405 feet. Okay, and let's go back down to our diagram to find how much fencing is needed. So we know that this is 28.405, this is 28.405, and the width is 8.803. So we have to add all those together, find our total, and that's going to be how much fence is needed. So let's see. And then I'm going to add 8.803. So I get 65.613 feet. That's the amount of fencing needed.